Hello everyone, welcome to today's video. I'm Clifford Mwenda, a GMAT trainer with the Kenya Leaf program. And in today's video, we'll be tackling simple and compound interest. For this topic, I'll be continuing from the sequential percent changes that we used, and I'll be using that idea to build the compound interest formula. And without much further ado, let's jump into the video. As a disclaimer, I'd like to you all to note that you don't need to memorize these formulas. You actually understand how these formulas are built, understand how especially the compound interest formula is built, deeply, so that you can answer some of the high-level questions that the GMAT throws at you. All right, without much further ado, let's jump into the video. All right, what's simple and compound interest? For simple interest, the interest is against the principal and not interest on interest. What I mean is interest for simple interest, it's the principal times the rate times the time, and rate in this case is a decimal. However, if you want to write it as a fraction, you can write it as principal times rate over 100 times time. All right. For compound interest, the interest is on interest. What do I mean by this? Given that you have first year, we can have principal times the multiplier, which is R. Let's put R as the multiplier. That's for the first year, and you'll get a PR. All right. What about the second year? The second year, the amount that you got from the first year, that's PR, and do it against the multiplier again, and you'll have a P times R, right? Which is a PR squared. And for the third year, consecutive year, you'll have this amount that you got from the second year and put the interest against it. So it's interest on interest on interest, and it gives about an exponential growth, which is PR cubed in this case. And as generally it's written as the total amount equals to the principal times the multiplier times the number of years. As you can see, for the third year, it was the principal times the multiplier power 3, which is the third year. All right. If P is the principal and R the rate multiplier, then A equals to P times R power Y, where Y is the number of years. In this case, Y being the number of years, if you're given an example where you're given a principal as 10,000, then you can have the rate of interest is 8%. For the number of years, let's say 5 years. In this case, the total amount will be the principal, which is 10,000, times the multiplier. In this case, it's not 8 over 100. Instead, interest of 8%, that the multiplier should be 1.08, as I mentioned in our previous video. In this case, we'll have 1.08 to the power of a 5. You don't have to do the calculation. The GMAT mostly puts such calculations for a number raised more than 2, that's squared, given that you have a cubed or to the power 4 to the power 5 all the way to infinity. The GMAT doesn't expect you to calculate such complicated math because you don't have a calculator, and therefore you can leave this answer at 10,000 into brackets 1.08 to power 5, right? And as you can see, this is familiar to you guys. The method usually given is amount equals to principal times 1 plus rate over 100. In this case, R is our rate to the power of the number of years. That's the usual formula. And in our case, 1 plus rate over 100, that's the multiplier. All this part is the multiplier. All right, and this is Y being the number of years, and P the principal. All right. What if the compounding period is less than 1 year? Compounded semi-annually, quarterly. These are compounding periods that you need to know. Given that N is the compounding period number, therefore, for semi-annually, in an year, how many semi-annual compounding periods are there? There are 2. For the quarterly, We have 4 for the monthly. We have 12 for the daily. We have 365. So you need to know these compounding periods in an year or annually. And in our case, if the compounding period is less than 1 year, given that it's semi-annually, quarterly, monthly, or daily, then the number of n, the compounding periods is n, then the expression is divided, where you have this rate of interest here is divided by the number of compounding periods, which means it's r over n times 100, all the way to all to the power of y. In this case, it's not in years instead of compounding periods. So how many compounding periods are there in those number of years? Given that this rate in our example is compounded quarterly, for example, how can we find the total amount? The total amount then is given by principal 10,000 times 1 plus the rate here is 8 over 100 times the number of compounding periods in an year for quarterly is 4. Therefore, it's 8 over 100 times 4. Then all to the power of the number of years was 5. And how many quarterly compounding periods are there in 5 years? There are 5 times 4 compounding periods. Simplify or solve this calculation and you'll have 10,000 times 1 plus, in this case 4 cancels, a factor of 4 can have 1, a factor of 4 you have 2. 2 over 100 equals to 0.02 all the way to the power of 20, and that comes to 10,000 times 1.02 power 20. All right. And how can we compare the compound and the simple interest? I'll just draw a simple graph to show you what I mean by comparison. The simple interest is usually linear. Say a simple interest is given by that line on the graph. Then the compound interest usually outperforms the simple interest in such a manner. Here, given the number of years and the total amount. Therefore, this compound interest every time outperforms the simple interest. And therefore, given that you have a compound interest question that you need to find the actual value, and it's a bit tough, you can use the simple interest to estimate the compound interest. By calculating the simple interest, find the values that are above the simple interest value, right? Give this question a try, then I'll jump in. All right, Leona bought a 1-year 10,000 certificate of deposit that paid interest at an annual rate of 8% compounded semi-annually. Note that this is semi-annually. What was the total amount of interest paid on this certificate at maturity? We have our principal as $10,000 at 8% semi-annually. What was the total amount of interest paid on this certificate at maturity? So the total amount equals to the 10,000 principal times the multiplier. In this case, we need to use the rate is compounded semi-annually, therefore you can separate these two values and have 8 over 100 semi-annually times 2. There are 2 semi-annual compounding periods in an annual or in an year to the power of the number of years, which in 1 year, both are 1 year 10 certificate deposit. Therefore, it's 1 year, and how many compounding periods are there? There are 2 semi-annual compounding periods. This simplifies to a 10,000 to a factor of 2. You can have 2 there, factor of 2 have 4. That's 1.04 to squared. Since we don't have this expressed in the answer choices, we need to simplify this further and actually calculate this calculation. And how can we do this easily? We can do this as 1.04 squared equals to 1 plus 0.04 squared, which is 1.04. Yeah, like that. We can FOIL this using algebra. The first value is 1 squared plus outer value is 0.04. Inner values, that's 0.04. Last values, that's 16 with 4 decimal places. Add this together, this is 1 plus 0.08 plus 0.0016. This adds up to 1.0816, right? This times the 10,000, therefore the amount will be 10,000 times 1.0816 is equals to 10,816, $10,816. That's the total amount. And you asked, what was the total amount of interest paid on this certificate at maturity? Instead of the total amount, we need the actual total amount of interest. And how do you do this? We do the 10,816 minus the principal. We have $816 as the total amount of interest. And our answer is C. Please pause the video and give this question a try. Then I'll jump in.
You are watching Success with Bob Mwiti Show, presented to you by Upstack America. Upstack America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstackamerica.com. Upstack America, we wake you up to the unlimited potential.
So in this case, we don't need to write out the formula. All need to notice or use logic in this question. Sorry about that. The amount of, if the money is invested at R% of interest, in this case, 8% is our R, compounded annually, right? Both of them are compounded annually. The amount of investment will double in approximately 7 over R years. Notice that this R is the same percent interest, right? So in this case, what will be the approximate total amount of the investment 18 years later? If in 70 over R years, the amount will double. So we know that 70 over, in our case, R is 8%, divided by 8, that's 35 over 4. That's approximately 9, all right? So in 9 years, the amount will double. What about in 18 years later? If Patrick's, say Pat's parents invested the 5,000 at first. After 9 years, this amount will double and it'll have 10,000, right? In the next 9 years, the amount will also double and have about 20,000, right? So in these two of these pairs of 9 years, that's 18 years later on, from 5,000 we'll have at 20,000. Understand the question and understand the logic behind this question. And for this case, our answer is A. Please pause the video, give this question a try, then I'll jump in. All right, Robin invested a total of 12,000 into investments X and Y, so that the investments earn the same amount of simple annual interest. How many dollars did Robin invest in investment Y? So we have the A, B, C, D, and E. Robin invested a total of 12,000 into investments. So we don't know how the two investments were shared between the X and Y investments. And this earned the same amount of simple annual interest. This is a simple interest question. How many dollars did Robin invest in investment Y? In this case, we need the number of dollars. This is a value question, and we need a specific value for the number of dollars that Robin invested in investment Y. All right. For investment X paid 3% simple annual interest, and investment Y paid 6% annual interest. So we know that first from the question, we know that X plus Y equals 12,000. We also know from statement 1, investment X paid 3% simple annual interest, which means for investment X, the interest equals to 3%, that's 3 over 100 times the number, that's X. For investment Y equals to 6 over 100 times the value of Y. In this case, the investment X and Y, these are in a unit time. Therefore, you need to have to add the value of T because they're all the same. You can add the value of T, that's unit time. And this interest and this interest are equal. So you can just equate this equal to this equation. And you'll have, for the first value, you can have 0.03x 0.03x times the value T equals to 0.06y times the value of T. And you can have 0.03x equals to 0.06y. You can find the, you can make X the subject to the formula and replace X, in this case, find the value of Y, and you can have your value of Y. Therefore, statement 1 is sufficient. And therefore, B, C, and E are out. In statement 2, Robin invested more than 1,000 in investment Y. Or does this, does it give any substantial information that you can find the values of X and Y? No, we don't know. This is ratio information. We know that X value is more than 1,000, can have different values and actually have the same interest. And the values of Y are actually different. I can give this a try. In this case, give X and Y 6,000 each. So if X is 6,000 and Y is also 6,000, with both having an interest of 10%, we can have the interest of X as 6,000 times 10 over 100, right? And can have interest of Y as 6,000 times 10 over 100. All right, these are equal. Therefore, you can have the value of Y, the interest of Y, or you can have the value of actually Y is 6,000 because the interests are the same. And in another option where you can have X as 2,000, therefore the interest of X will be 2,000 times, and say the interest of X is 50%. You can have this as the zeros go out and have 10 and the 2 zeros, that's 1,000. For interest of Y, let's give Y 10,000 with an interest of 10%. This case, there's cancel out and have also 1,000. Therefore, the interests are the same, but the value of Y here is 10,000. And the values of Y in the other place was 6,000 for the other example, right? So as you can see, these Y's are not the same. We need one unique value of Y. And we can't find one unique value of Y. Also, Robin invested more than 1,000 in investment X. For both X's, it's more than 1,000. Therefore, statement 2 is not sufficient. And D is not our answer. Our answer is A. All right, Vlad invests $4,000 at 5% interest rate, compounded semi-annually. So for Vlad, can have amount equals to the 4,000, which is the principal, times 1 plus 5% compounded semi-annually, that's 100 times 2. For how long? And Pavel invests 4,000 at 5% into simple interest. How much interest does Vlad earn than Pavel after 1 year? So after 1 year, compounded semi-annually, that's 2 compounding periods. And that's for Vlad. For Pavel, the interest should be 4,000 times 5 over 100 times 1 year, right? In this case, the amount should be 4,000 times 1 plus 2.5 over 100 squared. This adds up to 4,000. 1 plus 0.025 squared, and that equals 4,000, 1.025 squared. We can calculate this part first, since we need these actual values. We don't have this formula expressed in the answer choices, and that should be 1 plus 0.025 squared, 1 plus 0.025. Let's fold this and have 1 plus, for the first ones, outer ones 0.025, inner ones 0.025, and for the last ones you can have 0. Let's since it's 0.625 with 6 decimal places, 1, 2, 3, you can have like that, 0.000625. Add this all together, you can have 1 plus 0.05 plus 0.000625. This brings to 1 plus 0.05. These are 3 decimal places, 0.625. Well, this is 1 plus 1.050625. We need this times 4,000. This times 4,000. How can you do this? We can eliminate this for 3 zeros, or say do this 1.050625 times 1,000. That will give us a 1, 0, 1,000. That's 3 and half 1050. 0.625 times 4. All right. Let's continue with that calculation. We'll have 1050.625 times 4. Let's double and halve these expressions. Halve this and double 10.1050.625. After doubling this, we can have 1050 plus 1050.625 plus 1050.625. This equals to 1045. This is 12. This is 1. This is 10, 1, and this is 2. All right. So we'll have a 2101.25 times 2. Double and halve once more, or just double straight ahead, and we'll have this as 4202.5. Right. This is the total amount, but we need the interest. Since you asked about how much interest does Vlad earn than Pavel after 1 year, so minus the 4,000 principal, and we'll have 202.5. This is the interest that Vlad earned, and for Pavel, this is 4,000 times 5 over 100, since 1 multiplied by any number is still the number, and a factor of 100 from the denominator and a factor of 100 from the numerator, and we'll have 20 and a 0. That's 200. So you can see the interest that Pavel earned was 200, and the interest that Vlad earned was 202.5. But how much does Vlad earn more than Pavel? Let's do 202.5 minus 200. That should be $2.5. As you can see, the compound interest always outperforms the simple interest. Our answer here is B. All right. Thank you guys for your time. I hope this session was eye-opening or interesting, or if you actually enjoyed the video, please like, subscribe, and if you have any questions, please put it in the comment section below. Thank you. You guys have a nice day.